Now, as we return to the Homewood Suites in Los Angeles International Airport, and we've been doing the quantum mechanics application of the amazing 5x12 matrix, and we have come upon the quantum mechanics applications and the matrix mechanics, via the magnetization properties of the amazing 5x12 matrix and the PDM processing. All right, let's continue with what we're doing here. We're doing Pauli's spin matrices and the Dirac matrices derived from the Pauli's matrices, quantum mechanics. And what you have is, that alpha y, that is this alpha spin in y direction, is equal to 0, sigma 2, 0. And we know that sigma 2 was the Pauli's matrix, 2 by 2, which was given by 0 minus I, and 0. That was for sigma 2 here, this 2 by 2 matrix here. And notice it's the same thing for sigma 2 in this other, the 2 by 1, the 2, row 2 and column 1, which will be the same 0 minus I, and 0. Diagonally, sigma 2, and diagonally, these 2 by 2s are congruent or equal. Same likewise, this 0 in that direction, 0, and totally 4 by 4 matrix. Now, alpha z, the spin of alpha particle in the z direction, 0, sigma 3, 0, and the Dirac matrices now, or the Dirac matrix, will be now 0, 0, 0, 0, 0 in this diagonal, and sigma 3 in this diagonal. Sigma 3 was equal to the Pauli's matrix of 1, 0, 0, minus 1, 1, minus 1, 0, minus 0, which is this one. Sigma 3 diagonal equal, and equal in direction. Now the alpha x spin was equal now to 0, 0 in that diagonal, and sigma 1, which was the Pauli's spin matrix. And sigma 1 was given by 0, 1, 1, 0, which was a Markov matrix, square matrix, with the rows and column adding up to 1. And sigma 1, so this would be 0, 1, 1, 0, 0, 1, 1, 0, diagonally, they were congruent, and likewise 0, 0 coming in this diagonal was congruent. So that was the spin for the alpha x, and this was the Dirac matrix, and the alright, so we have the exponential fashion of it now would be e to the sigma x pi by 2 times now sigma y e to the minus I sigma x pi by 2 was equal now to I sigma x sigma y times minus I sigma x, which is equal now to sigma x sigma y sigma x. And that was equivalent now to this 2 by 2 Markov matrix 0, 1, 1, 0, and 0 minus I, y, 0, and this other Markov matrix 0, 1, 1, 0. And it's equal now to 0, I, minus I, 0, which is equal to minus sigma y. Now we could go on now to just write the product of these matrices now. The product, that's now sigma x squared is equal to 1, and sigma y squared is equal to 1, and sigma z squared is equal to 1. I know that sigma x, sigma y was equal to minus sigma y, sigma x equal to I sigma x. And sigma y, sigma z is equal to minus sigma z, sigma y equal to I. And that sigma z, sigma x is equal to minus sigma x, sigma z equal to I sigma y. So that is now the product of the spin matrices. And notice how we have in our view here now another visionary scope, the OMAX scope, which we have just have in the background, but we'll be looking at it in more detail after we have concluded our quantum mechanics and matrices mechanics application. enhanced by the AMZ5x12 matrix and PDM processing, and looked at in review the old quantum mechanics reasoning and the Heisenberg reasoning, the Schrodinger reasoning, and the Dirac and the Pauli spin matrices, all are in the quantum mechanics processing. Okay, let's take a break and then we'll come back. What I want to do tonight at the Homewood Suites also is to go back to some first principle in our AMZ5x12 matrix and into the economics configuration and into some circuit analysis to conclude, and also to bring about some biomedical processing in matrix by using the matrix, the biomedical definition of matrix, and we'll be looking it under the microscope and make some further biomedical applications. So we'll take a break and then we'll come back to look at our OMAX microscope and to see our AMZ5x12 would enhance some biomedical processing.